In Lesson 11, we will be adding and subtracting fractions and mixed numbers. As you view the tape, take careful notes. If I do a problem or explain a concept that's not clear to you, cut the tape off and find a tutor for help. Let's begin by looking at a picture of some fractions that we want to add. Here I want to add 1/4 to 2/4. And if you just counted up your fourths and put them all together, you could certainly see that we'd end up with 3/4. 1/4 plus 2/4 equals to 3/4. If you wanted to write down a rule to tell somebody what to do, you could tell them that as long as you have the same denominator, you could just add up your numerators to get your answer. So I could say A over B plus C over B would give me A plus C over B. Or if I were subtracting, it would work the same way. A over B minus C over B would equal to A minus C over B. Notice my B is my common denominator, and it has to be a number other than 0. So our rule is to add or subtract fractions with the same denominator, add or subtract their numerators, and keep the denominators the same. Now once you do that, you reduce your answer if possible. So let's look at an example. If we wanted to do 5, 6, subtract 1, 6, since our fractions have the same denominator, we can just work with our numerators. 5 minus 1 would give us 4, 6. And that 4/6 is not reduced, so we need to reduce it. We need to divide each part of it by 2. And we'd end up with 2/3 as our answer. Let's look at another one. Suppose we wanted to do 7/18 plus 17/18 plus 2/18. In this one, our common denominator is 18, so we can add our numerators. 7 and 17 is 24, and 2 is 26. That would be 26/18. And if you notice, 26 and 18 can both be divided by 2, so let's do that. And that would give me, you can see, that would give me 13 ninths. 13 ninths. Now that 13 ninths could be left like that, and that would be fine for our answer. Or we could divide 9 into 13 and say our answer was 1 4 ninths. Something else we might have done is the 26/18 that we got for our answer. We could have, if we liked, divided 18 into 26 to begin with and gotten 1 8/18. Then reduced both of those and have gotten 1 4 ninths that way. But our answer, we either need to leave as 1 4 ninths, or we need to leave it as this 13 ninths. It's fine to leave it improper as long as your common factors of 2 are divided out. Or if you prefer, you can make it a mixed number. But even if you make it a mixed number, you need to make sure you divide out these common factors. So the correct answer would either be 13 ninths or 1 4 ninths. Now let's look at an example to add in which our denominators are different. Suppose we want to add 1/4, so I have a picture of 1/4, and I want to add 3/8, and I have shaded in 3/8. Now I want to try to figure out a way to determine what my answer is. So what I really want to imagine doing is taking this 1/4 and putting it over here in that 8th circle so I could see how much I would have. Well, it would make it much easier if I could divide it up into the same divisions as that. So let's take each of these divisions and let's divide all those in half. And when we do that, I've made this one turn into 8s too, so my 1/4 became 2/8. So I can take the 2/8 and the 3/8, and see, it would be like I put the 2/8 here, the 2/8 and the 3/8, and put them all together, and I'd end up with 5/8. So in order for me to be able to tell that the answer was going to be 5/8, what I needed to do was to get the same divisions, get the same denominator. And so that's what my rule is going to say. When you're adding or subtracting fractions with different denominators, one must first change the fractions to equivalent fractions with a common denominator. So you cannot add two fractions that have different denominators until you change them to equivalent fractions that have the same denominators. Once you do that, then you follow the rule that we had before. In other words, what I just did in my picture was change that 1/4 into 2/8 up here in my picture. Then I could add my 2/8 and my 3/8 and get the 5/8. And then, if you needed to at that point, you would then reduce. Let's begin by adding some fractions that have different denominators. Or let's do some examples of those. We have 1/10 plus 5/6. Probably will be easier for you to follow if we put those under each other. So let's do that. And now we need to find the common denominator that we want to use. So if you remember from a previous lesson, if you start with your biggest denominator, your 10, and see if 10 will work as your common denominator. So we see if 6 will go into 10. If it won't, then we start taking multiples of 10. We try 10 times 2 and get 20 and see if 6 will go into 20. And it won't, so let's try 10 times 3. And we get 30, and 6 will go into 30. So 30 would be our common denominator. So I would put 30 down as my common denominator. And then I would begin to change each fraction into the equivalent fraction. What we're doing is we're building up these fractions by multiplying by whatever we need to turn it into a 30. So here I need to multiply by 5 to get 30. So if I multiply 6 by 5, I have to multiply 5 by 5. So I'd end up with 25 30ths. On top, I'd work with the 10 and try to turn 10 into 30. To turn 10 into 30, I'd have to multiply by 3. If I multiply 10 by 3, I have to multiply 1 by 3. So I end up with 3 30ths. So now I'm ready to add because I have the same denominator for each fraction. So I'm going to take 3 30ths and add it to 25 30ths, and I would get 28 30ths. And then I need to make sure I couldn't reduce that. If you look at 28 and 30, you'll realize that 2 will go into both of them. So let's divide 2 into 28 and get 14, and 2 into 30 and get 15. So our final answer would be 14 15ths.